Hi, geometry friends. We have come to the end, the final chapter of our text. And I'm excited about that, but I'm also excited because it's a pretty cool chapter. We're going to start chapter 13 talking about representing sample spaces. Our vocabulary includes this idea of what a sample space is. And basically, a sample space is defined as all the possibilities within a particular experience or experiment. So if I were to roll a die, let's say a six-sided die, the sample space, if I just roll it once, could be only one, me rolling a one, a two, three, four, five, or six. Make sense? Those are the only possible things that could happen. We could have sample spaces that are a little bit more complex depending on the number of experiments that are happening consecutively, and so we'll talk about that. One really good way to organize a situation like that when we have several different things happening is a tree diagram. So for instance, I could talk about each student will roll a die, and then after that, depending on their number, they will choose from a deck of cards that are either red or blue. I don't know, something like that. And so what you would have in a tree diagram is if you have a situation where somebody is rolling a die and then flipping a coin, what would a tree diagram look like in terms of this situation? So rolling a die, we know that there's only six things that can happen. One, two, three, four, five, and six. So this is the first thing, the first several options that can happen. Now with each of these options, you can flip a coin and you can get either heads or tails, or heads or tails. You guys see where I'm going with this. And so for each of these, you would have, after rolling the die, no matter what value you get, you can get heads or tails if the next event is to flip a coin. And then the question could be, well, how many different outcomes can happen? Well, I've got one and two and three and four and five and six. So a tree diagram helps me see all of the possibilities, in a sense, the entire sample space kind of laid out and organized in a way where I can see sometimes the likelihood of each event happening. The other phrase that I'd like to draw your attention to is one we actually just kind of thought through, is the idea of a two-stage experiment. And that's exactly what that was. If we were to first roll a die and then flip a coin, that would be a two-stage experiment. If we had a situation where we did a little bit more, or two stages. If we had three stages, it would be considered a multi-stage. So a multi-stage experiment is having two or more different experimental things that can happen. For instance, flipping a coin and then, I don't know, pulling a sock out of a bag depending on the number of socks in a bag, something like that. Finally, the fundamental counting principle, we're going to get to this a little bit later. It kind of stems a little bit from the idea of the tree diagram, but it really basically comes down to the idea that you can multiply in order to figure out the number of possible things that can happen. So if I were to pick, for instance, a three-digit number, and I were to think about how many three-digit numbers are there, then I have to think about how many digits each one of these things could be, right? So the first number could be any of 10 digits from 0 to 9. The second number can be any from 10 digits from 0 to 9, and so could the third. So how many different possibilities this is? Well, the fundamental counting principle, which we're going to learn a little bit more about, tells me to multiply all of those possibilities, and then I get the total number of possibilities. And so in this case, that number would be 1,000. Okay, so there's 1,000 different three-digit numbers that I can have, and that's not particularly earth-shattering, right? That kind of makes sense to you guys. And so that's the fundamental counting principle, and it kind of relates nicely to some other things. With that in mind, let's get started. So here's example one. It says represent a sample space. A coin is tossed twice. Represent the sample space for this experiment to make by making an organized list, a table, and a tree diagram. All right, we can do this. So making a list basically helps me think through what are the two things that could happen. So I could have pulled heads on the first one and heads on the second one, right? Or heads on the first one and then tails, or tails, then heads, or tails, then tails again. this is the list of all the possibilities, and I pretty much, think logically through it to make my list. A table might make a little bit more sense, might help you organize so if you had more things going on, you wouldn't miss a certain situation. So our table could look something like this. So our table could represent maybe across the top the possible choices that could happen in the first toss, and then along the side the possible choices that could happen in the second toss. And so for the first situation, the first outcome, we could have heads and then another heads, right? And then for this one, we could have tails on the first toss and then heads on the second toss. Again, heads and tails, and then finally tails and tails. So this is a way of organizing it in a tabular or table form. And finally, we could think about it in terms of the first toss gives us two choices, heads, then tails, and then each of these tosses, after each toss, we could still have the option of, again, another pair, another head and another tail. And so this is what our tree diagram would look like. We could then finalize our diagram by showing what each branch reveals. It reveals that we have heads, actually heads and heads here, right? Over here, this shows me the option where we'd have heads and tails. This one, tails and heads, and finally tails and tails. So what we recognize here is that in either way, in either of these ways, we're going to find that we get the same sample space. So I really do like the idea of tree diagrams, and they do help organize information really nicely. And we're going to use a tree diagram rather, to represent this problem. So hamburgers, we've got Keandra, and she asks each customer the question from the script shown. And we're going to draw a tree diagram to represent that. I promise I can say it. Okay, what size burger would you like? Kids, regular, or large? So when you pull up, you've got three choices, right? You've got kids, you've got a regular, or a large, right? So you make that decision. Then what would you like? Would you like cheese on that? So you've got two choices here. You can go with cheese, or I'm going to use N for no cheese. And so each option gives you cheese or no cheese, and again, cheese or no cheese. Would you like tomato and or pickle? All right, so now this is a little bit tricky, but we can handle it. So in this last bit, we can choose to have a tomato and pickles, or tomato and no pickles. So I'm making this real deep, right? So if we start off, we could either get a tomato, and after choosing tomato, we can choose to have pickles, or let's do NP, no pickles. Or we could choose not to have a tomato, but we'd still have the option of pickles and no pickles. All right, you guys see where I'm going with this. I'm going to try to resize this so each C and C and C and will have the same options, just so we can kind of get a visual. And this is what our complete tree diagram would look like, okay? So let's take a generic look at our fundamental counting principle. And so basically what the principle is telling us is that if we think about the number of experiments that we might have along the way. So we might have, let's say, K experiments. So in a way, like if you think about this situation, we had the three questions kind of represent three different stages in the experiment. I would have actually organized this slightly differently to kind of reflect that, because this makes it a little bit hairier. But anyway, basically, there's three stages in the experiment, right? So we've got the one, the two, and the three. And what we could do is think about multiplying in order to figure out how many different possible, in this case, orders that you could have. So if we look at the counting principle, it's going to ask us to consider all the stages and the number of possible outcomes at the first stage, second stage, all the way up to the kth stage. And what you're going to do is multiply all of those different outcomes to figure out all the possible outcomes in general. For instance, I'm going to take a quick sidebar. So, for instance, what if I had a life where I wanted to keep myself very simple, and I decided I'm going to buy 5 shirts, I'm going to buy 4 pairs of bottoms, and only 2 shoes, and I'm going to wear this for the rest of my life. And that's my decision because I want to keep my life simple. And so I decided to get decorative colors, as you can see. And so basically, what happens is if I wanted to ask myself, or if I wanted to figure out how many different outfits I get, according to the number principle, I would take the 5 different shirts that I have, multiply that by the 4 different pairs of bottoms, and then multiply that by the 2 different pairs of shoes. And this would give me the total number of um, different kinds of clothes, or it would tell me different types of outfits, and it would give me my sample space. So for me, I'd have 40 different outfits. Not bad for somebody keeping it simple. We're going to use the fundamental counting principle here in example 3. Class rings. Haley has selected a size and overall style for her class ring. Now she must choose from the ring options shown. How many different rings could Haley create in her chosen style and size? So we see that she's got 10 choices of metal, 2 choices of finishes, 12 different stones, 5 stone cuts, side 1 activity logo, there's 20 different things she could have, like baseball and soccer. And side 2, again, 20 different ones, like, I don't know, drama or whatever. And then band style, she's got 2. So how many different types of rings could she choose, given all of the different choices? If you were considering multiplying all of these numbers together, you would be exactly right. And so basically, we multiply all the choices together as the fundamental counting system asks us to do, and then we get our answer. So after multiplying these together, I end up with 960,000 different choices for our friend Haley and her ring. Okay, so I hope that you guys understand kind of what we went through today. Just kind of a quick recap. We talked about the fundamental principle of counting, where we can multiply each of the number of possible outcomes at each stage of our experiment. We looked at tree diagrams and how they can help us kind of think through our situation. We also talked about lists and tables in a way of representing our situation. We've used the language sample space and 2-stage experiment, multi-stage experiment, tree diagram, and fundamental counting principle. Let me know if anything is troublesome. I look forward to talking to you soon. Bye-bye.